Move on, so if I can introduce Martin from this.
Hello, so I'm going to do three things here today. See what my three things are. But before I start, I'm going to do a quick test for you, see how old people are, how good your memories are. So, does anybody have a clue what that might be? And I'll say I saw this.
Transputer chip, is it? It's a transputer chip.
Good try. So I was at the Imperial College the other day for a meeting. Now in their physics department, they've got all these bits that they brought back from old CERN experiments. So that's the old CERN Atlas detector. They sort of brought some bits of it back within my little trophy cabinet. Now, I think it's quite interesting. You know, we think about the LHC, and we think, for instance, about the enormous compute power required to process the stuff that's coming out of it. It's very interesting to think, you know, about these one-of-a-kind bits of kit that are being produced for these kinds of experiments. And very much what we've been talking about today is off-the-shelf. You know, I want 100 of these. Now I want a petaflop-sized supercomputer. Just make that happen. But actually, a lot of the science, a lot of the fundamental science is driven by these one-of-a-kind instruments. So that's just my pretext for warming you up a bit, to get you to think a little bit after your big lunch. So my three things, I thought, and this was a bet that I made with myself, that I thought it might be useful to do a little kind of road trip through how we got here. And the other speakers here haven't really covered what I'm trying to cover, so I'm feeling quite relieved now, because I'm not just going to be repeating the same things you've heard already. I'm going to give you a sneak preview of something that you won't have seen, because no one's seen it yet, which is every year we do an annual survey of the UK e-infrastructure community. So this is universities, research centres, folk who have big compute and big data. So I'll give you a little sneak preview of what we're hearing from people this year. You'll be the first people to hear it. Later this afternoon, the HPC SIG, which is meeting up in Hull, will be the second lot of people to hear it. So you're actually hearing it first. And then I've got some thoughts of my own about what's next, and particularly in terms of software. So I had a brief to say a couple of words about software. So without further ado though, I probably ought to say a couple of words about where I'm coming from. So I work for JISC, and some of you probably know us through the Janet network, through things like EduRoam, JISC Mail, and most recently, and we've heard a few people mention this already, we've been working with some commercial partners to do shared data centres. So a lot of people in the past would have said, oh, you know, crikey, I've got to refurbish my data centre because some idiot's gone out and bought this £1 million supercomputer without talking to me about how it's going to go. Increasingly what's happened is people are saying to us, okay, actually we need to get a space which is of a quality and a standard that we would struggle to mobilise to do in-house. So actually it isn't necessarily just about, well, I just want to buy into something. It's also about the sheer cost involved in setting up a data center operation that you can do, for instance, quite sensitive workings. So if you're dealing with administrative data, some of the bioinformatics data. So a lot of people using these services, we think there's about 18 million people using them actually, but we're a not-for-profit, so a bit like, unlike some of the other people you've heard speaking today, we might want you to use our shared data centers, but actually we're not trying to make margins on it, we're just trying to serve the community. We do a lot of national deals, and folk who are in university and research institute sector, you probably use our deals for things like AWS, Microsoft, Azure and Office 365. It's got quite a few of those. Routers and switches framework, we don't do anything specifically for HPC right now. A lot of people buy equipment through those frameworks. Very interesting question for universities and research institutes here today is, do you think we should do something specifically for HPC? We do a lot of work in providing advice and guidance, so those are our kind of three pillars. My job is, I'm a futurist. I actually have the good fortune to be able to think about all kinds of stuff as well as HPC. So I used to run an HPC Seminar, but to give you an idea, just last week we were doing a lot of interesting stuff with brain interfaces. And if you say, okay, you're going to be plugging this thing onto your head, which is be monitoring what's going on in your brain, that sounds a bit sci-fi, doesn't it? 262 quid. You can buy this as a product, and this is what it looks like when you start to look at what's going on in someone's brain. You can actually use that to fly a drone. So hold on to that thought. You could be sat there in the park one day with your brain hat on, remote controlling a drone. And we were quite interested in this for research and education applications. Let's say you're a lecturer and you have a board looking at class of students in front of you. You could hand a few of these out. You might get a little bit of advance warning, kind of losing the audience now. Maybe I need to step it up a bit, put something else up on the screen. So I get around and do a fair few things. But I'd say I used to be an HPC Center manager, and I have been quite nerdy. So I've been on the journey myself. So this is the journey that I see, and it's really in 3 parts. So part 1, I haven't put timescales on this. You might have your own idea about timescales, and I think they might vary from person to person, from place to place. But I think we've all been there with handcrafted, optimized C code, Fortran code, sometimes even assembler, to get the absolute maximum throughput, the maximum amount of science and engineering, whatever the use case is, out of the equipment. But we've also seen, as an HPC Center manager, I saw a lot of this, people who took that hand-optimized, crafted artisanal code, and then they kind of bodged it together with lots of scripts and other things, and just somehow couldn't make all of these things into a workflow. So I remember looking at some quite incredible workflows that had Fortran code, C code, lots of different libraries written in other languages, which have all been linked together with Perl scripts and Python scripts and all kinds of stuff. And so we talk about high performance computing, and our expectation is that kind of pedal to the metal, floor it, let's go and use the thing to its utmost. And actually, if we're honest, there's an awful lot of this stuff around, even now. Problem with that, of course, is it's quite brittle. So if you say, well, actually, I want to move this from one place to another, well, you are using the exact right version of that library with the special compiler flags, which are the only ones that get you the right numbers, the same numbers that you got on the other machine that you did on before. All those kind of dependencies are very problematic. Wasn't it great that virtualization came along? Because virtualization meant that we could say, all those libraries, all those other versions of libraries, programs, system environment, no problem at all. What we'll do is we'll just wrap all that up in a virtual machine. That's great. And I can adapt this around here. Can you run my virtual machine? And of course, let's say as a researcher at a university, you turn up with a virtual machine and you say, well, I'd like to run this on your machine, on your supercomputer. And often the answer was, oh, okay, although it's a Linux image, and we're all running Linux here, it's all nice and simple. There's no way I'm going to let you run a VM on my HPC cluster for all kinds of reasons. I talk about those on slide 2. So VMs, huge potential, but I think there are a few obstacles on that journey. And I've also saw, particularly from the computer science community, a lot of very bright people saying, well, actually, we want to be able to move objects and data and move whole workflows around. We need some standards. We need a standard way of doing it so that we can just share things with each other. We don't have to reinvent the wheel each time. And I think one particular example here, which is research object. You can go to researchobject.org. Lots of great ideas. But this is a few years ago, and we're still really only at the beginning of that particular journey, I would say. We're probably much further on with the software than we are with the data, the workflows. So, okay, part 2. And again, your point on this journey is quite different to your neighbours, but number 2, the virtual machine becomes a common currency. So, you go to the AWS marketplace, you used to go to the Azure VM depot, and there's a whole bunch of virtual machines ready-made. Take them, fire them up, and go off and do stuff. And so suddenly with what else is doing to really turbocharge that. Great stuff. Well, it tends to be different formats for different providers, so you can't just take one standard interchangeable virtual machine format. You can use maybe a tool like QEMU, which some people may remember from the ancient dawn of history, about one virtual machine format to another, but that's not necessarily completely reliable. So there's a few little issues there, but the idea of virtual machine as unit currency, of course, has really taken up. So you can come not just to commercial things like the AWS marketplace, but I flagged BioLinux as an example. There's lots of community level stuff going on as well. I was going to use another site there called bioimage.org, which was, you'll note there's the key word, a repository for images that the bioinformatics community, VM images that they put together and wanted to share. It's gone. I was reading this great paper about it from 2015 that says, look at all this stuff we did, all these people contributed to it, but it's gone now. And that for me was very interesting. It was a community effort. Maybe the community wasn't strong enough. Maybe there was a key person who left. But
maybe they better manage.
We also see, in parallel, lots and lots of interest in what I call orchestration tools. But basically, it's things like Ansible, things like Vagrant, things like Puppet. Basically, give me a set of instructions to make the thing. So maybe you aren't sharing the thing itself, maybe you're sharing the recipe, the menu, a list of instructions, how do we build the thing. But even then, if I was an HPC sysadmin, somebody turns up with a virtual machine, and so I've got this thing, well, if I put that on my cluster, overlooking exactly how I did that, that's a virtual machine. We've got anything on it. And we heard from Lee earlier on about Rolls-Royce's situation. Let's say I pitch up with a virtual machine. Of course, I've got root access to this Linux image because it's mine. I made it. It's got loads of other stuff I don't actually use on there. But it's probably all safe. It's probably not going to cause any problems. Would you as the sysadmin say, yeah, come on board, fill your boots? You might be a little bit reticent. You might be a little bit cautious. And also, if you VM enabled your entire HPC cluster, then even just a couple of years ago, people would be saying, that's probably not a good idea. The performance would suffer. Let alone if there's a rogue VM that could be doing all of these bad things. If we VM enabled our HPC cluster, then all of a sudden everybody sees a performance hit. So, some people are probably still having that conversation. I remember there were a lot of people talking about that, and I personally encountered it maybe a couple of years ago. And then the third part of the journey was the realization that actually not everybody needs HPC jobs that are truly HPC. Not everybody needs jobs that involve hundreds of nodes, thousands of processor cores, and the sorts of things that people at HPC events often like to talk about, teraflop and petaflops. A lot of people, and I saw this very graphically as an HPC center manager, a lot of people pitch up with a job that only uses one node, a job that doesn't necessarily use all the cores on one node. And there are a surprisingly large number of those people. So we have this idea about, I want to use HPC in the cloud, I'm going to fire up a cluster, it's going to have hundreds of nodes, it's going to have, quite a lot of storage. And actually a lot of the people who came along looking for a platform for their scientific computing were running their stuff on a laptop. And their key consideration was, can you make this faster than my laptop? And the answer was always yes, because we use server-grade hardware, so, brilliant. Okay, yeah, we can make it faster than your laptop. But that question about superimposing a cloud environment on an HPC cluster, I think it's one thing in particular changed lots of people's minds about that. And I should have really put a graphic of that in. It was when CERN adopted OpenStack. And CERN didn't just go, oh, we'll have a little bit of OpenStack over the corner here. They said, well, if you're trying that, we're having OpenStack across the board. So all our hardware will run OpenStack, which means that it's inherently capable of running those VMs that the researcher turns up with. That still means, of course, you need to have some confidence that the VMs are actually not going to be malicious in some way. So that, I think, was really a light bulb moment, I think, for a lot of people. We've also seen things like Jasmine here that I picked up, where a community has come along and said, actually, we need our own private cloud. So the growth of public cloud, growth of OpenStack as the platform for running particularly an in-house cloud. But this idea that actually as a community, maybe it amplifies what we're doing for our facility is quite an interesting one. But underpinning all of that, of course, is the fact that cloud as a medium, it's not in-house, it's not public, it's as a way of doing things that's been gaining ground. And who's probably done the most to make that happen? Well, it's our friends at AWS. It's very hard now to separate public cloud from AWS. And you see this happen again and again and again. And really what people are thinking is, there is this new feature like AWS Lambda. I just want to run a bit of code in cloud. I don't want to manage a server. And if you think about this journey that we're on here actually ends up with, eventually with the researcher that the scientific computing used within a company becoming potentially a sysadmin. We've got these virtual machines. And suddenly there are hundreds of them. Who runs those? Is it the sysadmin to the cluster? Well, you turned up with a virtual machine to your stuff. I think you should run it, because I don't know what it is. So that's a real issue, and that's where things like AWS Lambda are very interesting. If I turn up with a bit of code, and I say, well, I just want to run this, I probably want to run a few 100,000 instances of it. Can you just auto-scale, run that when I need it, scale down again after? It's actually very, very attractive. So, history lesson over. It'll be interesting to talk later on about if your experiences match mine. But let's talk about the infrastructure survey. Some of you may have seen the reports we did in 2014 and 2015. So we're gearing up to do another one of these. We've done the surveying over the summer. So I know some of you in the room who've contributed to that, so well done. Thank you. It's hard work, but I think it's worthwhile. This is a list of people who contributed. So we do have Light Source, we do have University of Sheffield, well done, thank you, and many others. So what I'm saying here is that's actually a pretty good representation of what the UK HPC community, if we like the e-infrastructure community, on the academic side, primarily is doing. I know there's some blurring of boundaries because some people have quasi-commercial things going on. So we asked people to describe their service and the nature of their service. And in SurveyMonkey, there's this wonderful word cloud tool. So I use that to say, okay, what's really popping out here? Of course, HPC is commercial data center. So who would have thought that? That's very interesting. This, of course, is just a very high-level distillation of what we saw. Also, for me, research software engineering. It used to be that we would be talking about who runs the machine, who procures the machine, and increasingly we're talking about who is it who's helping you to get the most out of your investment in scientific computing, and actually having a research software engineering team, people who understand how to write the code that is transportable, isn't brittle, has reproducible results, etc. So that in itself, very interesting. We asked people what domains, what REF domains, Research Excellence Framework, their machines were used in. The results were very interesting because up here, you might not be able to read it at the back, 76% of the 50 or so respondents said biological sciences. Now you might have thought we're talking about principally HPC, so it's kind of hard engineering right at the top. So biological sciences, okay, closely followed by physics, closely followed by maths, 60% there with chemistry. Would you have expected chemistry to be so high on the list? So what I'm saying really is there are some surprises there. Some of the subject areas, some of the domains that you might have expected to see right up at the top, they're quite high up the list. I mean, to be fair, it does go on quite a long way. There are a lot of rough categories. But it's interesting to see right up at the top that pecking order perhaps a little bit different to what you might have thought. We asked people if they actively supported their users in using the cloud. And again, the answer would be, if we'd done this a couple of years ago, the answer would be, oh, I don't know about that. No, we don't hold with that. And so the answer now is 45%, and that's 40 institutions who answered that question. 45%, almost half of those institutions that we surveyed said, yes, we do. For me, that's rather significant. We asked them if they actually provide a service, or if they provide support in a meaningful way, and we gave them some ways of telling us about that. And 50% of them said, actually, we classify what we do as private cloud. So the idea that cloud is something that other people do, I think we've moved away significantly from that. And what we're saying now is, we see the thing that we run as a private cloud in-house. We still see that as cloud, which I think is very interesting. Do support and enable access to public cloud services, but a smaller number there. So that's 17%. That was 7 institutions that said that. So there is a little bit of an impedance mismatch there, maybe. Perhaps if we've come to see cloud as being something, perhaps principally that we do in-house, internally. And I mentioned OpenStack before. When we drill down to the text of the responses, there are only a couple of institutions that said, oh, and learning to drive OpenStack is part of it. And I think, again, because there is so much interest, we're seeing in procurements, there's so much interest in OpenStack. I bet you in a year or two's time, when we go back and we look at that, the numbers for OpenStack will be much larger. We asked people to tell us a little bit more about how they supported their users in using the cloud. And so the green is private cloud, the bluey colour there is public cloud. And it's very interesting to see, for instance, training, repositories of applications, help with porting applications, and help with cloud bursting. So there are particular themes where there's actually quite a bit of effort going in from those teams and institutions who, bear in mind, in the past might have been laser focused on the in-house provision. You see the blue lines there. There's actually quite a bit of effort going into those. So as an example, just under 50% of the 18 respondents to this question said, oh, actually we help people to port applications, work on cloud services. I think, if you'd asked that question a few years ago, the answer would probably have been, you're on your own there, mate. So very interesting to see. And we did drill down a little bit more into what that really means. So the idea that people are planning a significant cloud presence, for example. When you got 2 institutions that said that's what they were doing this year, I think they might be seeing a few more next year. When we asked people about secure repositories, data for processing facilities for sensitive data, quite a few said we have one of those. We're setting one up. Of the people who did, this is 13 respondents, 100% of them were talking about archiving virtual machines. So these are people who are providing facilities for dealing with medical records, sensitive administrative data, that kind of thing. So virtual machines are absolutely on the radar. But then, a bit I'll come back to in a moment, containers, nearly a quarter of them. So we tend to think containers as a whiz-bang new technology. But actually, those people are either being very forward-looking or it's here now. So it's interesting to think that. So I'm nearly done. I'll give you my throwaway thoughts before I sit down again. So I mentioned containers. The Open Container Initiative, when you look at the number and the nature of organisations that are participating in that, it seems pretty clear that although we might right now think containers equals Docker, and there was a time when we would have said containers equals Solaris, if you remember Solaris zones. If you think containers equals Docker, then you're missing a big part of the picture here, because all of those companies are heavily invested in containers as their next step on from here's a VM. It may be that Lambda actually bites the one above and Lambda wins in the end anyway. So it'll be interesting to see. But when we look at what the hyperscale providers can do, we talked about how public cloud doesn't necessarily have the kind of performance interconnects that you would get with an in-house machine. But we have seen significant steps forward with things like Azure's RDMA. So it isn't all about putting Ethernet in as an interconnect. Equally, with Azure's FPGAs, with Google's TensorFlow processing units, there's hardware in the cloud that you can tap into, which is state-of-the-art, which is not part of your procurement. You did your procurement 2 years ago, you want to add FPGAs to it all, right, that's actually quite a big deal. You can tap into it right now in public cloud. You can also tap into what I call very fat nodes. So if you're there thinking, well, what difference would it make if I had twice as much RAM in this node? What difference would it make if I had double the number of processing cores? Well, go and find out. That's a thing that is quite hard to do if you just want to try a few experiments out and you want the equivalent of half a data center over a weekend for your experiments. You can do it quickly and cheaply in public cloud. Something we're helping with is peering. So when you have a facility like Azure, like AWS, and getting a direct connection to the institution, with VPN that lets you transport IP addresses. We're seeing a lot of interest in this at the moment. Doing lots of work actually right now with Microsoft on ExpressRoute for that. I mentioned the kind of consolidation into community or domain clouds. A good example of that is the Climb project, which is the cloud infrastructure for microbial bioinformatics. So I managed to say it without tripping over it. So, and that brings people together from pretty much the entire microbial community, the research community in the UK. That is their facility. And in the past they might have lots of little things here and there. Now they have a big central facility which is well founded. Maybe we'll see more of that. But it does present lots of challenges around authorization and access. Who should have access to that data? Those people are working with Zika virus and Ebola. So it's actually pretty hardcore. You don't store that in a meaningful way on your computer, but you do interact with lots of data about individuals, patients, and so on. Will containers take over from VMs? I said a couple of things about that, but there is a catch. Right now, if you said, where do I go? Where do I go to find the Docker files that will let me build the image that I'm just going to run on my in-house facility or on my public cloud? They're scattered all over the place. And I mentioned the bioimage example earlier on. It's very interesting to me to see how that's gone. And it took us a while. Initially, we only had a Docker public image registry. So there was no way to have an image which was just for you, just for your products, your customers. We've gone beyond that. We didn't have any security model at all really for Docker to begin with. And now we've moved on a long way from that as well. Is there something that we need to do to create that kind of clearinghouse? Will products like Alsys actually serve that role? I think it'd be very interesting to talk about that. So that's been me. I hope you found that interesting. Hopefully there's one or two new things in there. Thank you very much.
Thank you very much indeed.
Cheers.